Hello everyone, welcome back to this online class. Today we are going to look at Runge-Kutta methods, and in particular we are going to look at the Butcher table, a case where you are given a Butcher table and you are supposed to use Runge-Kutta method to be able to solve any particular initial value problem. Now we have this question. We are asked to consider the following Butcher table. We are given the table there. Apply the above method to the IVP given by dy over dx is equals to xy squared, subject to the initial condition that y at 0 is equals to 1, with a step size h is equals to 0.1, compute the value of y of 0.2. So first of all, let me tell you how to interpret this table. Of course, the Butcher table will always give the coefficients of h, k1, k2, k3, and k4 in our definitions of K1, K2, K3, K4, and K. So this is how to interpret it. So if you look at the left side of the vertical line, those are the coefficients of H. So I'll write here H. And so all these are the coefficients of H. To the right of the vertical line, the first column, those will give you the coefficients of K1. The second column to the right will give you the coefficients of K2. The third column, coefficients of K3, and the fourth column, coefficients of K4. Now, let us complete this table. Those spaces that you see there, those are zeros. So just insert them so that I tell you how to apply this. So here we have a 0, another 0 here. Again, here is 0, 0, 0. And here 0, 0, 0, 0. And now look at the vertical line, not the vertical but horizontal line. The values just below it, those will give you the coefficients of K1, K2, K3, and K4 in your definition of K. So now, look at our ODE. We have f of xy given by xy squared, and the 0 here is x naught, and the 1 here is y naught. But before we embark on the initial value problem, first of all, let's interpret the Butcher table. So you can write here, interpret the Butcher table. So we start with the K1 is equals to, now what you do, this is, of course, it is always h times f of xn. Now it means to the xn you need to add 0 times h. So we are going to add 0 h, comma, then we have yn, then plus, what are we adding? We are adding 0 times k1 plus 0 times k2 plus another 0 times k3 plus 0 times k4. So that is 0 k1 plus 0 k2 plus 0 k3 plus 0 k4. And if I simplify this, I'm going to get h f of xn, comma, yn. Similarly, k2 is equals to h f of xn. What are we adding? It is 1 over 3 times h. So plus 1 over 3h, comma, yn, we are adding 1 over 3k1 plus 0k2 plus 0k3 plus 0k4. So that is 1 over 3 k1 plus 0k2 plus 0k3 plus 0k4. Again, if you simplify this one, you need to get h f of xn plus h over 3, comma, yn plus k1 over 3. Let's proceed to k3. So our k3 from the Butcher table is h f of xn. What are we adding? It is 2h, not 2 but 2 over 3h. So that is plus 2 over 3h, comma, yn. We are adding negative 1 over 3k1. So that is negative 1 over 3k1. Then I can see plus 1k2, or 1k2, plus 0k3 plus 0k4. 0k3 plus 0k4. So if you simplify this, you're going to get h f of xn plus 2h over 3, comma, yn minus k1 over 3 plus k2. The next is k4. K4, that is equals to h f of xn. What are we adding? Is 1h plus 1h, comma, yn. Here we are adding 1k1 plus negative 1k2 plus 1k3 plus 0k4. So you'll have here plus 1k1 plus negative 1. That's the same as, let me just write negative 1k2 plus 1k3 plus 0k4. Again, if you simplify this one, you need to get h f of xn plus h, comma, yn plus k1 minus k2 plus k3. And finally, the last row, just the row below the horizontal line, that will give us the definition of k. So our k is equals to, this means it is 1 over 8k1, 1 over 8k1, plus, here it is 3 over 8k2, plus the other one is again 3 over 8k3, plus the last one is 1 over 8k4. If I simplify this, I'm going to get, because I can see 1 over 8 is common, so I factor out 1 over 8 into k1 plus 3k2 plus 3k3 plus k4. So that's the interpretation of the Butcher table. As I said previously, that Butcher table will always give you the coefficients of h, k1 all the way up to k4 in our definitions of k1, k2, k3, k4, and k, as you can see. Now, from our initial value problem, what are we given? So you can write from the IVP, we have f of x. Let me start with x naught and y naught. We have x naught is equals to 0, y naught is equals to 1. Of course, h is 0.1. And our f of xy is equal to xy squared. So from here, it means that our f of x n y n is the same as xn times yn squared. And then you see we are asked to find the value of y of 0.2. This is what we have, an illustration. We have here, we have x naught, which is 0. Our step size is 0.1. So 0 in steps of 0.1, that will give us 0.1, the next x value. The next one is 0.2. We want to stop up to there. So remember, this is x naught, x1, x2. What is the corresponding y values? Here it is when x is 0, y is 1. What about the value here? I don't know. Neither do I know this. So what it means that this is y naught, this is y1, and this is y2. So our task is to find y1 and y2. And remember, when we write y1, it's the same as y at x1. And this the same as y when x is 0.1. We don't know this, so I'll have a question mark. And when I write y2, is the same as y at x2, and that's the same as y when x is 0.2. I also don't know this, a question mark. Now, remember we are iterating from n 0, 1, all the way up to the last one, that is when n is 2. And you know that your yn plus 1 is always equals to yn plus k. So once you have found k1 all the way up to k4 and also the value of k, you simply need to substitute your values here so that you get y subscript n plus 1. And so in this case, our n is equals to 0, 1, 2, etc. So we are iterating. Let's start with n0. We see what you're going to get. So you can say put n is equals to 0. What are you going to get? It will give us y1 is equals to y naught plus k. So let's find the value of k, but before we find k, we need to find k1 all the way up to k4. So we start with k1. It is equals to h f of x naught, y naught. You see, it was h f of x n, y n, but in this case, n is 0. That's why I'm using x naught, y naught. And we know the value of x naught and y naught. But look at our definition of f of x, y. It is xy squared. So it means when I talk of f of x naught, y naught, where there is x, I'm going to put x naught, and where there is y, I'm going to put y naught. So this will give us x, for this h, we start with h into x naught times y naught squared. Our h is 0.1 into our x naught, that was 0, y naught is 1, you need to square this, and the result will be 0. That's our k1. Let's proceed to find k2. So k2 is equals to, look at our definition, it is h f of, let's go back to our definition of k2. It is this one here, xn plus h over 3, yn plus k1 over 3. But remember, n is 0, so that will give us x naught plus h over 3, comma, y naught plus k1 over 3. And this is equals to h. Remember, our f of xy is equals to xy squared. So where there is x, I'm going to put x naught plus h over 3. And where there is y, I'm going to put y naught plus k1 over 3. So this will give us x naught plus h over 3 times y naught plus k1 over 3, and this is squared. Substitute the values of x naught, y naught, h, and k1, and then press in your calculator. That should give you the value of k2 to be 0.0033, 0.0033, and another 3. Correct to 6 decimal places. Next, we compute k3. That should be h f of x naught plus 2h over 3 y naught minus k1 over 3 plus k2. And so that is h. Our definition of f of xy is xy squared. So where there is x, I'm going to put x naught plus 2h over 3. Where there is y, we'll have y naught minus k1 over 3 plus k2. So that is x naught plus 2h over 3 times y naught minus k1 over 3 plus k2. And remember, it was y squared, so we square this. Substitute the values of x naught, y naught, h, k1, and k2, and then press in your calculator. You should be able to get the value of k3 to be 0.006711. 0.006711. K4 is equals to h f of x naught plus h y naught plus k1 minus k2 plus k3. So our f of xy is x times y squared. So where there is x, in this case, I'm now going to put x naught plus h, and where there is y, I'm going to put y naught plus k1 minus k2 plus k3. So we'll have h x naught plus h times y naught plus k1 minus k2 plus k3. And this is squared. Substitute the values of x naught, y naught, h, k1, k2, and k3, and press in your calculator. That should give you the value of k4 to be 0.010068. 0.010068. We are rounding off to 6 decimal places. So with those, we can now be able to find k and y1. So you can just say that therefore, our k is 1 over 8 into k1 is 0 plus 3 times k2, which is 0.003333 plus 3 times k3, 0.006711 plus k4, 0.010068. If you press this in your calculator, you need to get 0.005025. 0.005025. And so our y1 is equals to y naught, which is 0 plus k, 0.005025. This should give you 0.005025. So this is the value of y when x is equals to 0.1. So let us comment on this, and you write this is the value of y at 0.1. So far we have found this y1, I found it. Let's now find y2. So we go to the next iteration now when n is equals to 1. That will help us find y2. So I found this one. Another iteration, we write put n is equals to 1. Put n is equals to 1. So what are we going to get? It will be y2 is equals to y1 plus k. Before we compute k, let us compute k1 all the way up to k4. Then we use the values to determine the value of k. So we start with k1. K1 in this case now will be equal to h f of x1 y1, and that is equals to h into x1 squared, not x1 squared, but it is x1 times y1 squared. Y1 squared. Remember our f of xy was xy squared. So where there is x, I'm going to put x1, and where there is y, I'm going to put y1. And so it will be x1 times y1 squared. That is equals to 0.1. Our x1 was 0.1. y1, we have just found it to be 0.005025. We need to square this. Press in your calculator. You need to get the value of k1 to be 0.010101. That is correct to 6 decimal places. 01. Proceed to find k2. So our k2 in this case will be equal to h f of x1 . So f of x1, what are we adding? H over 3 y1 plus k1 over 3. So this should give us h into x1 plus h over 3 y1 plus k1 over 3, and this is squared. Because our f of xy is xy squared. So in place of x, you put x1 plus h over 3. And in place of y, you put y1 plus k1 over 3. So substitute the values of x1, y1, h, and k1, and press that in your calculator. That will give you the value of k2 to be 0.013558. 0.013558. K3 is equals to h f of x1. What are we adding? It is 2h over 3. Then y1 minus k1 over 3 plus k2. And so this is equals to h. Look at our definition of f of xy, that is xy squared. So where there is x, I'm going to put x1 plus 2h over 3. And where there is y, you put y1 minus k1 over 3 plus k2. So that should give us x1 plus 2h over 3 times y1 minus k1 over 3 plus k2. This is supposed to be squared. So substitute the values of x1, y1, h, k1, and k2, and press in your calculator. That should give you the value of k3 to be 0.017178. 0.017178. Finally, let's compute k4. So our k4 is equals to h f of x1 plus h y1 plus k1 minus k2 plus k3. Based on our definition of f of xy, which is xy squared, this should give us x1 plus h times y1 plus k1 minus k2 plus k3. And this is supposed to be squared. Substitute the values of x1, y1, h, k1, k2, and k3, and press in your calculator. That should give you the value of k4 to be 0.020757. 0.020757. Now with this, we can be able to find the value of k. So you say therefore k is equals to 1 over 8 into our k1 now is 0.010101 plus 3 times k2, which is 0.013558 plus 3 times k3, which is 0.017178 plus k4, 0.020757. So again, press this in your calculator. That should give you the value of k to be 0.015383. So this is 0.015383. And so y2 is equals to y1, which we got as 0.005025 plus our k, which is 0.015383. Press in your calculator. You need to get the value of y2 to be 1.02020408. That is correct to 6 decimal places. So this is the value of y when x is 0.2. So we comment on this and you say this is y at 0.2. So that's what you are required to find, and we have found the value correct to 6 decimal places. So thank you all for watching this video. Please subscribe to my YouTube channel, that is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we look at more problems involving the Runge-Kutta method. But before I finish the lecture, remember our y naught was 1, not 0. So instead of 0 here, this ought to be 1. So this should be 1. Remember. And so even here it is 1. So this is 1. That was a y naught. Even here it is 1. Even here 1 point, not 0 point. Take note of that. But the rest are okay. So thank you all. Let's meet next time. Bye-bye.